Welcome back. We're going to do Unit 11, Lesson 8, Binomial Expansions. And this is actually a really neat topic. It's actually kind of fun to do once you figure out the pattern. And I must say, if you are ever on a blind date or waiting for your appetizer to arrive, like I tell my kids all the time in school, this would be a great problem to know how to do to show your date to impress them. All right, let's get started. So binomial expansion. So that means we're going to be dealing with, obviously, a binomial. So let's see what they have us ask us to do. Consider expressions of the form x plus y raised to the n. So any binomial raised to any power for values of n that are non-negative integers. Quickly expand each of the following. Well, anything raised to the 0 power is 1. X plus y raised to the first is x plus y. X plus y squared, so we're getting a little bit more difficult here. So this would be x squared plus 2xy plus y squared. Using your answer to x plus y squared, expand it and do x plus y quantity cubed. So let's see here. I'm going to have x squared plus 2xy plus y squared times x plus y, all right? And I'm going to go ahead and tab this out. Or if you're more comfortable, you could not use FOIL because it's a little bit more complicated than FOIL. You could, distribute it out. Okay, so I have an x squared, I have a 2xy, I have a y squared. So x squared times x is going to be x to the third. 2xy times x is going to be 2x squared y. Y squared times x, xy squared. And when I'm doing this, I try to keep my variables in alphabetical order just for organization purposes. X squared times y is going to be x squared times y. 2xy times y, 2xy squared. Y squared times y is y to the third. So if you do it correctly, your diagonals will be like terms. So I have x to the third. This diagonal right here, x squared, x squared. I have 2 in this box, 1 in this box. So that's going to be 3x squared y. Plus, now this diagonal, xy squared, I have 2 xy squareds in this box, 1 in this box, so that's a total of 3 xy squared plus y to the third. What is true about the powers of x? What is true about the powers of y? So let's take a look. Right here, I'm going to do it in yellow. My powers of x went from 3 to 2 to 1 to none. Okay, let's see. Maybe the powers of y are doing the same thing. So the powers of y went from none to 1 to 2 to 3. So it appears that the powers of x are descending, meaning going down, while the powers of y are increasing or ascending. What is true about the sum of the powers of any given term? All right, so let's look at this term right here, x to the third. The sum of the powers of this term, well, this term has a degree of 3. This term also has a degree of 3 because I take the power of x, which is 2, and add it to the power of y, which is 1. 2 plus 1 is 3. The degree of this term is, well, x is raised to the first, y is squared, 1 plus 2 is 3. The last term is nothing to add, so it's just a 3. So what is true about the sum of the powers of any given term? All terms have a power of 3. I wonder if that power of 3 had anything to do with that. I guess we'll have to continue on and see what happens. So here is your binomial expansion pattern, and this can also be found in your reference table, so don't feel like you have to memorize it. But when you start to learn how to do these, they become so routine that you're not going to need to refer back to your reference table, but it is there just in case you need it. Use the pattern above to expand x plus y to the fourth and the quantity of x plus y raised to the fifth. All right, so let's take a look at this. it says whatever the power of n is, right? So in this case, it would be the fourth. That n value goes here. And then, all right, so let's see. Actually, I think I don't even want to go through the formula yet. I want to show you the example. So if I was to expand the quantity of x plus y raised to the fourth, it's going to be 4, choose 0. Then I'm gonna do 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. So all I did was I took my power, right? That went on the left-hand side, and then I went from 0, 1, 2, 3, 4. Okay, simple enough. Now I have to figure out what's happening with this term right here. Well, as we said before, the powers of x are decreasing. So it's going to be x raised to the fourth, x raised to the third, x squared, x to the first, and then x to the 0. Now I'm going to deal with this part of the binomial. And we had said before that the y's are ascending, meaning they're increasing. So y to the 1, y squared, hopefully you can see that, y to the third, y to the fourth. So there's 3 parts to each of these. And what we're going to do next is we're going to calculate these. So you're going to have to, again, use your graphing calculator. 4, choose 0 means that you're going to have to hit the math button. You're going to have to arrow over to the right to find PRB. And you're going to go down to choice 3, which is NCR. 4, choose 0. And then you're going to do x to the fourth. Well, x to the fourth is just x to the fourth. Y to the 0 is 1. And did you figure out what 4 choose 0 was? That was also a 1. So 1 times x to the fourth is just x to the fourth. We're going to move on to the next line. 4 choose 1. If you type that in your calculator, you get a value of 4. Then I have x to the third, y. 4 choose 2 gives you a value of 6. Then I have x squared, y squared. 4 choose 3 has a value of 4, x, y to the third. And the value of 4 choose 4 has a value of 1. X to the 0 also has a value of 1. And then we have y to the fourth. So if I rewrite all these and I add them all up, I'm going to get x to the fourth plus 4x to the third y plus 6x squared y squared plus 4xy to the third plus y to the fourth. And now I'm going to notice, remember, we raise this to the degree of 4. Let's check each individual term. This term right here, x to the fourth, has a degree of 4. 4x to the third, y to the first, 3 plus 1 is 4, 2 plus 2 is 4, 3 plus 1 is 4, and then just a 4. So they all have a degree of 4. Now let's try it for something raised to the 5th power. So this time we're going to start with 5 choose 0, 5 choose 1, 5 choose 2, 3, 4, 5. All right, so now we're going to remember the powers of x are descending. So it's going to be x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, x to the 0. The powers of y are going to be ascending, meaning going up. Okay. Let me get some green here. So 5 choose 0 has a value of 1 times x to the 5th times y to the 0, which also has a value of 1. So this one is just x to the 5th. 5 choose 1 has a value of 5, x to the 4th y. 5 choose 2 has a value of 10. And remember, I am putting these values in my calculator with the math going over to PRB, down to choice 3, and picking NCR. This one is 10x squared y to the 3rd. This one is 5xy to the 4th. And then the last one, 5 choose 5 is 1, x to the 0 is 1, y to the 5th. And if I write all these guys out, I get a value of x to the 5th plus 5x to the 4th y plus 10, and I'm writing kind of small. Sorry about that. And just as before, each term has a degree of 5 because that was what I was asked to expand. Okay, let's see what's on the next page. I can hardly wait. Completely expand. All right, so now we have a binomial. We don't have x and y raised to the fourth. Write it in simplest standard form. Check using a table on your calculator. We're not going to do that part. We're just going to completely expand it. All right, so I have a 4, so I know I'm going to start with 4, choose 0, 4, choose 1, 4, choose 2, and 4, choose 4. And actually, I don't like the way those 4 looks. They should be little. Sorry about that. I want to make sure I'm being, let's see, so 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. Okay, so that takes care of the first part. Now, this is where my x was located last time. So this value, this 2x, is still going to go in ascending order. So it's going to be 2x. Oh, and listen to me. It's going to go in descending order. It's going to start with the fourth, 3, 2, 1, none. Now we're going to take care of this value, which this was is in the y spot, and it's a -1. So now the y values, if you recall, these ones go in ascending order. So it's going to be -1 to the 0. -1 to the first, -1 squared, -1 to the third, and -1 to the fourth. Okay, now here comes the part where we could potentially make a mistake. Okay, 4 choose 0 has a value of 1. 2, the quantity of 2x raised to the fourth, well, that would be 2 raised to the fourth power, which is 16, and then x raised to the fourth. -1 raised to the 0 has a value of 1. Anything raised to the 0 power is 1. So this first term is 16x to the fourth. The next one, 4 choose 1, has a value of 4. The quantity of 2x raised to the third power, well, that would be 2 raised to the third power, which is 8. X to the third power, and the value -1 raised to the first power is still going to be -1. So this term is going to be -32x to the third. Next term, 4 choose 2 has a value of 6. 2x, the quantity of 2x squared, has a value of 4x squared. -1 squared has a value of 1, so this term has a value of 24x squared. 4 choose 3 has a value of 4 times 2x raised to the first is 2x. -1 raised to the third power is -1, so this term has a value of -8x. 4 choose 4 has a value of 1. 2x raised to the 0 has a value of 1. -1 raised to the fourth power has a value of 1. So the last term is 1. So when I write this out in simplest standard form, I'm going to have 16x to the fourth minus 32x to the third plus 24x squared minus 8x plus 1. A variation on these type of problems would be not to write out the entire polynomial, but to find the value of a specific term in the polynomial. So let's see, which of the following represents the third term when written in standard form of 3x plus 2y raised to the 6th? So I'm going to kind of do this the same way, and I'm going to start out by saying, okay, here's my exponent. So I have 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3. But wait a minute. I don't need to keep going because they asked for the third term. So this would be the first term, the second term. So this is what I'm going to concentrate on. So really, I don't need this, I don't need this, and I don't need this. So then I'm going to take 3x. And you're probably saying, well, how do I figure out what values, what exponents to use? Well, this value right here is always this exponent. So if this is being raised to the second power, they have to total a value of 6. So this is going to be to the 6th. And if I calculate this, 6 choose 2 has a value of 15. Then I have 3x raised to oh, I'm sorry, look at me. I just said they had to add up to 6. So this has to be a 4. I'm sorry about that. So now I have 3x raised to the 4th power. 3 to the 4th power has a value of 81. X to the 4th. Then I evaluate 2y squared. 2 squared is 4. Y squared. So now I'm going to multiply 15, 81, and 4. I get a value of 4,860. X to the 4th, y squared. So again, this asked me for the third term, so I started out by listing 6 choose 0, 6 choose 1, 6 choose 2. This value right here gives me the value of this exponent, and I know they had to total 6, so 2 plus 4 happens to be 6. When written in standard form, which of the following represents the middle term of the expansion, 2x minus 3 raised to the 8th? I definitely would not want to have to write that whole polynomial out. All right, so here we're going to start. 8 choose 0, 8 choose 1, 8 choose 2, 8 choose 3, 8 choose 4, 8 choose 5, 8 choose 6, 8 choose 7, 8 choose 8. Now they want the middle term, so cancel, 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 cancel. Cancel, 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 and I'm sure you probably could have figured that out on your own, but just to be thorough, so I'm going to do my work over here. So I have 8 choose 4, I have 2x, and I have a negative 3. Again, I know that this value here is this exponent. 4 plus what totals 8? Well, this has to be a 4. The value of 8 choose 4 has a value of 70. 2x raised to the 4th. 2 to the 4th has a value of 16. X to the 4th. Negative 3 has a value, negative 3 raised to the 4th power is 81. If I multiply 70 times 16 times 81, I get 90,720 x to the 4th. And this was choice 4. And just a word of advice, when you enter negative 3 raised to the 4th power in your calculator, please, please, please make sure to use the parentheses. If not, you will get a wrong answer. If written in standard form, the last term of the expansion of 3x minus 2y raised to the 6th power is, well, instead of me writing out all those values, are you able to figure out what would the last term be? If it's going in increasing order, so 6 choose 0, I would get all the way up to 6 choose 6. I have my 3x, my negative 2y. I know that this value right here goes here. 6 plus what is 6? This is going to be raised to the 0 power. 6 choose 6 has a value of, 1. So this has a value of 1. This has a value of 1. Negative 2 raised to the 6th power has a value of 64. And then y to the 6th. So that would be choice 1. Which of the following represents the exponent of x? Okay, so a little bit more of a variation on the second term of the expansion of x squared minus 1 divided by x raised to the 4th. All right, so let's see. The first term would be 4 choose 0. The second term would be 4 choose 1, and that's what we want. And they want the represents the exponent of x. So let's keep going. I don't like what I see yet. So let's see. So I have x squared. I have negative 1 over x. If you remember, this value of 1 goes here. So 1 plus 3 has a value of 4. Remember, your exponents always have to total your 4 or whatever exponent it's being raised to the power. So let's see. 4 choose 1. 4, x squared raised to the 3rd, remember power to a power you multiply, x to the 6th, And negative 1x raised to the first power would just be negative 1 over x. So if I rewrite this, I have 4, negative 4x to the 6th divided by x. If you remember, like bases, you subtract your exponents. So this has a value of 4x to the 5th. So it says, which of the following represents the exponent of x? Well, the exponent of x has a value of 5. So that would be choice 2. All right, so just to summarize, this lesson was on binomial expansions. The formula can be found in your reference table. It is this crazy thing right there, but hopefully you'll have enough practice by the time the Regents comes that you won't even need to reference it. And thanks for tuning in.